This piece is an absurdist and comedic play written by Eugene Ionesco, and it's basically about a old professor who's tutoring a new student. As the play goes by, the professor starts getting heated and really angry to the student since the student really couldn't understand what he was teaching. And in the end, the professor actually ends up killing the student, and then another new student arrives. So the story just repeats itself.
Good! Then shall we arithmetize a little?
I'll be pleased to, sir.
Then perhaps you wouldn't mind telling me
Not in the slightest, sir. Please go ahead.
what do 1 and 1 make?
1 and 1 make 2.
But that's very good indeed. You're extremely advanced in your studies. You'll have very little difficulty in passing your doctorate examinations.
I'm very pleased to hear it, sir, especially from you.
Let us proceed a little further. What do 2 and 1 make?
3,
3 and 1?
4,
4 and 1?
5,
5 and 1?
6,
6 and 1?
7,
7 and
8.
1. Very good answer. 7 and 1?
still 8,
Excellent. Perfect. 7 and 1?
8 again,
Well, 7 and 1?
8 for the 4th time, and sometimes 9.
Magnifique, you're magnificent, sublime. My warmest congratulations, mademoiselle. There's no point in going on. You're quite first-rate at addition. Let's try subtraction. What is left when you take 3 from 4?
3 from 4? 3 from 4?
Yes, I mean to say, what is 4 minus 3?
That makes 7.
I'm extremely sorry to have to contradict you, but 3 from 4 doesn't make 7. You're muddling it up. 3 plus 4 makes 7. 3 take away from 4, and that makes... It's not a question of adding up. Now, you have to subtract.
Yes, I see.
3 from 4, that makes... how many? How many?
4?
No, mademoiselle, that is not the answer.
3 then.
That's not right either, mademoiselle. I really do beg your pardon. It doesn't make 3. I'm terribly sorry.
4 minus 3. 3 away from 4. 4 minus 3, I suppose it wouldn't make 10?
Oh, dear me, no. Mademoiselle, but you mustn't rely on guesswork. You must reason it out. Shall we try and solve it together? Would you be so good as to count?
Yes, sir. 1, 2, 3.
You know how to count, all right? You can count up to what number?
I can count up to infinity.
That's impossible.
Miss? Then
That's
up
impossible.
to 16.
That's quite far enough. We must all recognize our limitations. Go on counting then, if you please.
Okay, 1, 2, after 2, 3, 4.
Okay, stop there, mademoiselle. Which number is greater, 3 or 4?
3 or 4. Which is the greater number out of 3 and 4? In what way greater?
Some numbers are smaller than others. In the greater numbers, there are more units than there are in the smaller ones.
Than in the smaller numbers. In that case, small numbers can be bigger than big numbers?
Yes, well, we won't get into that. That would take up far too much time. I just want you to realize that there are other things apart from numbers. There are sizes too, and totals, and there are groups and heaps of things like ducks and drakes and cabbages and kings, etc., etc. Let us suppose, to make it easier, that the numbers we're dealing with are all of the same kind. Then the greatest numbers will be those that have the most units, assuming all the units are of the same kind.
The one that has the most will be the greatest? Now, I understand, sir. You are equating quality with quantity.
That's a little too theoretical. Mademoiselle. You don't need to worry about it. Let's take an example and think it out in that particular case. We have the number 4 and the number 3, each one having a number of identical units. Which number will be the greater? The smaller number or the greater number?
I'm sorry, sir, but what do you mean by the greater number? Is it the one that is less small than the other one?
That's it, Mademoiselle. Exactly. You've understood it perfectly.
Then it must be 4.
What is 4? Greater or smaller than 3?
Smaller? No, it's greater.
Excellent answer. How many units are missing between 3 and 4, or between 4 and 3, if you rather?
There aren't any units, sir. Between 3 and 4, 4 comes immediately after 3. There is nothing at all between 3 and 4.
I can't make myself understood properly. It's doubtless my own fault. I haven't been clear enough.
Oh no, sir, the fault is entirely mine.
Listen, here are 3 matches. 3 matches. And here is another one. That makes 4. Now, watch carefully. There are 4 of them. I take 1 away. How many do you have left?
5. If 3 and 1 make 4, 4 and 1 make 5.
No, that's not right. That's not right at all. You have a constant predilection for adding up, but it is also necessary to subtract. Integration alone is not enough. Disintegration is essential too. That's what life is, and philosophy, that's science, progress, civilization.
Yes, sir.
Let us get back to our matches. I have 4 of them. You can see that there are 4, all right? I take 1 away, and that leaves me with...
I don't know, sir.
Come down, think a little. It's not easy, I admit, and yet you're clever enough to make the intellectual effort required in succeeding in understanding. Well then...
I don't seem to, sir. I really don't know.
Alright, we'll take some simpler examples. If you had 2 noses and I'd pluck one of them off, how many would you have?
None.
What do you mean none?
Well, it's just because you haven't plucked one off that I've still got one now. If you had plucked it off, it wouldn't be there anymore.
You didn't quite understand my example. Suppose you only had 1 ear.
Yes, and then?
I stick another 1. So how many would you have?
2.
Good. Okay. I stick yet another 1 on. How many would you have?
3 ears.
I take 1 away. How many do you have left?
2.
No, you have 2 ears. I take 1 away. I nibble 1 off. How many do you have left?
2.
I nibble 1 of them off. 1 of them.
2.
1.
2.
1.
2.
1.
2.
1. is not it at all. The example is not convincing enough. Listen to me.
Yes, sir.
You have
I have 10 fingers.
okay, good. If you like, fine. You have 10 fingers. Then
Yes, sir.
how many would you have if you had 5 of them?
10, sir.
No, that's wrong.
But I should, sir.
I tell you, you're wrong.
But you've just told me that I have 10.
And then I told you immediately afterwards that you had 5.
But I haven't gotten 5. I've got 10.
Let us proceed in a different way. Let us, for the purpose of subtraction, limit ourselves to the numbers 1 to 5. A little patience, mademoiselle, and you'll see, I'm going to help you understand. Now watch, mademoiselle. You can see, all right?
Yes, sir.
Okay, so these are all sticks, mademoiselle. Sticks, you understand? This is 1 stick. Then there are 2 sticks. 1, 2, 3 in all. Then 4 sticks, 5 sticks, and so on. 1 stick, 2 sticks, 3 sticks, 4 sticks, and 5 sticks. Those are numbers. When you count the sticks, each stick is a unit. Mademoiselle, repeat what I've just said.
A unit, mademoiselle. Repeat what I've just said.
Either figures or numbers 1, 2, 3, 4, 5, the elements of numeration, mademoiselle.
Yes, sir. Elements, figures that are sticks, units, and numbers.
At one and the same time, that is to say, in point of fact, the whole of arithmetic boils down to that.
Yes, sir. Very good, sir. Thank you, sir.
Now then, you can count, if you like, making use of these elements. Add up and subtract.
The sticks are figures and numbers and units.
In a manner of speaking, then what?
You can subtract 2 units from 3 units, but can you subtract 2 twos from 3 threes? And 2 figures from 4 numbers? And 3 numbers from 1 unit?
No, mademoiselle. You cannot.
But why not, sir?
Just because, mademoiselle.
Because what, sir? Since they're all the same?
That's just the way things are, mademoiselle. It can't be explained. You understand it by a sort of mathematical sense inside you. Either you've got it or you haven't.
Then nothing can help me then.
Listen, mademoiselle, if you don't succeed in fully understanding these archetypal arithmetical principles, you'll never succeed in carrying out your work properly as a polytechnician. And what's more, no one will be able to put you in for a course at a polytechnic school or even an establishment for infants. I confess, it is by no means easy. It's obvious that it's very, very abstract. But if you've not mastered these elementary propositions, how can you ever hope to make mental calculations such as, and this would be as easy as winking to an average engineer, such as this. For example, how much is 3,755,998,251 multiplied by 5,162,303,508?
That makes 19 quintillion, 390 quadrillion, 2,844,219,164,508.
No, I don't think so. That must make 19 quintillion, 390 quadrillion, 2,844,219,164,509.
No, 508.
Yes, you're right. By Jove, yours is the correct product. quintillion, quadrillion, trillion, billion, million, 164,508. But how did you arrive at that? If you don't understand the principles of arithmetical calculation.
Oh, it's quite easy, really, as I can't depend on reasoning it out. I learned off by heart all the possible combinations in multiplication.
But the combinations are infinite.
I was able to do it.
It's quite outstanding. Nevertheless, you will allow me to point out to you that I am by no means satisfied, mademoiselle, and you must do without my congratulations in mathematics, and particularly in arithmetic. What counts, and you can't get away from counting in arithmetic, what counts above all else is the ability to understand what you are doing. You ought to have found the answer by a dual process of inductive and deductive mathematical reasoning, and that is the way you should arrive at all your answers. But memory is a deadly enemy to mathematics, and though it has certain advantages, arithmetically speaking, memory is a bad thing. And so, I'm not happy at all about you. That just won't do at all.
No, sir.
Well, forget about it. Forget about it for the moment. Let us pass on to another kind of exercise.
Yes, sir.